Alright, so a question about analyzing this circuit. So the way I handle it, I always do my VI table over here, and I'll number my circuits and my resistors here. It doesn't really matter the order. So 1, 2, 3, 4, 5, and 6. So add column here. 3, 4, 5, 6, and then my totals. So I know my total voltage is 9. Okay, so resistance. So we find that total resistance. So the first thing I do is I'm going to work on the circuit in here. So I got to crunch this one down. So that's kind of step 1. It's in parallel. So 1 over RT equals 1/8 plus a quarter. So we have an eighth plus a quarter. And then we're going to take the reciprocal. So that's 3/8, 1 over RT. RT equals 8/3, and I mean, we can 2.7 is good enough for what we're working with here. So we have crushed down that first resistor. Now I'll change colors here just to kind of help out. So I know my resistance here is 2.7. These guys, so this will be step 2 in red. So step 2 those are in series. So that means we can just simply add those together. So in step 2, we're just going to take the 6. So our total equals 6 plus 2.7, which gives us 8.7 ohms. All right, and just make myself the room here to stay on the same board. So now changing over to blue. So now I have 10 ohms, and on this other pathway I have 8.7. So for stage 3, it's in parallel. So 1 over RT equals a tenth plus 1 over 8.7. And I mean that through the calculator, and then well, I guess I'll do the extra step here. So a tenth, 1/10 plus 1 divided by the 8.7. So that's say 0.21. I'm just leaving it on the calculator here. So reciprocal of that is 4.7. All right, so there is those 4 resistors are now crushed down into 1. And that allows me then to find the total resistance on the pathway. We have 1 pathway left. So stage 4 here, I guess I'll move to black. So total resistance would be the 4.7 I just calculated, plus we have 5. There's my 5 and my 0.5. So adding those together, so plus the 5.5, we get, we'll call it 10.2 ohms. So that then gives me total resistance here. So up just a hair, so 10.2 ohms there, 9 volts, so V equals IR. So 9 divided by the 10.2. So my current is 0.88 amps. All right, so that's the tricky part. And I don't think that was actually your particular issue. The issue is figuring out the rest of the information, or someone dealing with that messy circuit. So I'm going to erase this circuit because I'm going to draw it in again when I do some explanation here. Oh, of course. Can't lose my numbering, so I'll hold on a second here. So putting the resistances on. So 0.5. Number 2 is a 10. Number 3 is the 6, 8, 4, and 5. Okay. So starting at the battery, so starting right here, all the current has to go through there. So all the 0.088 or 0.88 amps is going to go through that 0.5 resistor. Similarly, when it comes through here over at 6, all the current has to go through there. So 0.88 has to go through that one. So that allows me to figure out how many volts have been used up through those 2 resistors. So 0.44 here, and times the 5 is 4.4 there. All right, so how much has been used? I started with 9 volts, so that's the battery, minus 0.44 minus 4.4. So we plug that through the calculator to figure out how much is left to go through that messy part of the circuit. So I'm going to call it 4.2 volts remaining. So when we get to the junction point, and then I'm going to have to remember the numbering on my circuits here. So when I get to this point right here, I have 4.2 volts to use up. If I am an electron and I choose this pathway, then I only have one resistor to overcome. So that means I have to use up all 4.2 volts on that pathway. So for the 10 ohm resistor, my voltage is going to be 4.2. I have to use it all up on that pathway. Now doing that, I can find the current, how much current is going that way. So 4.2 divided by 10 is 0.42. So I know that 0.42 amps are going that direction, which means I can figure out how much current's going this way, going the other pathway, because we know that total amps is 0.88. We know 0.42 goes the other way, so we're left with 0.46 amps heading in the opposite direction. Now, as we go through the circuit, at 0.46, everyone's got to go through the 6 ohm resistor. So I know my current through number 3 has to be the 0.46. So now I can figure out how many volts are used there. So 6 times the 0.46 is 2.76. Let's call it 2.8. All right. So this resistor right here, I'm going to pass. I know that 0.46 current, all of that had to go through there, and 2.8 volts was used. Now, I started with the 4.2. I'm going to subtract off an additional 2.8 because that's been used up on the pathway. I'm down to 1.4 volts. So at this juncture, right here, there's 1.4 volts. So as an electron, I can choose to go that direction or that direction, but regardless, I have to use up the 1.4 volts. So that means regardless which way I go, I will be using up the remaining 1.4 volts, and that will then tell me how to break up that current. So 0.18 went that way, and 1.4 divided by 4 is 0.35 that way. All right, so there is the full circuit analysis with a whole bunch of writing on it. Hopefully that clarifies it. The current is the big thing. The current always has to add up to 0.88. So for example, one pathway here, so it's 0.88. All right, one pathway here is 0.88. When it goes into and splits up here, right here, all right, it has to add up to 0.88. So that would mean that going through the 10 ohm resistor, that current, and going through the 6 ohm resistor, if you add those together, 0.42 and 0.46, you get back to your 0.88. All right. When you get onto this pathway, of course, I make a huge mess. On this pathway, the current always has to add up to that 0.46. All right. So going through the 6 ohm resistor, there's your 0.46, and it splits apart. But if you add that up, that gets us pretty close back to 0.46. Okay. Hopefully that clarifies how to do your circuit analysis. If you have any questions, let me know. But hopefully that kind of steps you through it.